The fourth dimension, beyond the boundaries of human perception. For centuries, human beings have understood the universe through three familiar spatial dimensions: length, width, and height. Every object around us occupies these dimensions, shaping the way we experience reality. Yet modern mathematics and physics suggest that the universe may be far more complex than our senses can perceive. Among the most intriguing ideas in science is the concept of the fourth dimension, a subject that has fascinated mathematicians, physicists, philosophers, and science fiction writers for generations. But what exactly is the fourth dimension, and why does it continue to inspire both scientific research and public imagination? A useful way to approach this concept is through a simple thought experiment. Imagine a creature living in a completely flat, two-dimensional world, where only length and width exist. Such a being would have no understanding of height because it lies beyond its experience. If a three-dimensional sphere passed through this flat world, the creature would not see the sphere itself. Instead, it would observe a circle appearing from nowhere, growing larger, shrinking again, and finally disappearing. To the two-dimensional observer, the event would seem impossible, even though it would have a perfectly ordinary explanation from a higher-dimensional perspective. This idea was famously explored in Edwin Abbott's classic novella Flatland, published in 1884. Abbott illustrated how beings confined to a limited number of dimensions cannot fully understand realities beyond their perception. Likewise, if a true fourth spatial dimension exists, humans might only observe its effects rather than the dimension itself. Mathematically, extending geometry into higher dimensions is surprisingly logical. A point has no dimensions. Connecting two points creates a line with one dimension. Moving the line sideways forms a square, and extending the square upward creates a cube. Continuing this pattern leads to a tesseract, or hypercube, the four-dimensional equivalent of a cube. Although impossible to visualize directly, mathematicians can describe the tesseract precisely using equations. The most familiar scientific interpretation of the fourth dimension, however, is not another direction in space but time itself. In the early 20th century, Albert Einstein transformed physics by showing that space and time are inseparable parts of a single four-dimensional structure known as spacetime. According to Einstein's theory of relativity, every event has both spatial and temporal coordinates. Massive objects such as stars and planets bend the fabric of spacetime, creating what we perceive as gravity. Instead of imagining gravity as an invisible force, Einstein described it as the natural result of moving through curved spacetime. This revolutionary idea has been confirmed repeatedly through observations, including the bending of light around the sun, the precision of GPS satellites, and the detection of gravitational waves. Despite these successes, some physicists believe additional spatial dimensions may also exist. String theory, for example, proposes that the fundamental building blocks of the universe are tiny vibrating strings rather than point-like particles. Interestingly, the mathematics behind this theory works best in a universe containing 10 or even 11 dimensions. The extra dimensions, if they exist, are thought to be tightly curled up at incredibly small scales, making them impossible to detect with current technology. Although there is no direct evidence for these hidden dimensions, scientists continue searching for clues through particle accelerators, astronomical observations, and studies of gravity. Whether these dimensions are eventually discovered or not, they demonstrate how scientific theories often push the limits of human imagination while remaining grounded in mathematics and experimental testing. The fourth dimension has also influenced art, literature, and popular culture. Cubist artists experimented with representing multiple perspectives at once, inspired partly by discussions of higher dimensional geometry. Meanwhile, countless novels and films have used the fourth dimension to explore time travel, parallel realities, and hidden worlds. Although these fictional interpretations often differ from scientific theories, they reflect humanity's enduring curiosity about what may exist beyond ordinary perception. The fourth dimension reminds us that reality may be far richer than it appears. Throughout history, science has repeatedly revealed phenomena that were once invisible or unimaginable, from atoms to black holes. Whether the fourth dimension represents time, an unseen direction in space, or a powerful mathematical concept, it challenges us to think beyond everyday experience. More importantly, it highlights one of science's greatest strengths: its ability to expand not only our knowledge of the universe but also the limits of human imagination.